Hello and welcome to Factive, your home for knowledge in 5 minutes or less. My name is Sean, so sit back, relax, grab a coffee because today you'll be learning how an airplane flies. And who knows, after this video, your friends may mistake you for an aerospace engineer. Let's get started. Picture this. You wake up and find yourself 35,000 feet above sea level going 600 miles per hour. Are you dreaming? Did you come into contact with a radioactive wombat and become a superhero? Unfortunately, no. You are sitting on a cramped commercial jet. With nothing else to do, you begin to wonder, how does this 155,000-pound behemoth stay in the air? Thankfully, you had the foresight to download this episode of Factive before takeoff. Good for you. The mechanism behind controlled flight begins with that age-old question. Do you even aerodynamic lift, bro? So let's dive in. Just like any good gym bro knows, gains begin with the fundamentals. In this case, we need to understand lift. When air flows around an object, it exerts two forces on the object, one perpendicular and one parallel. The perpendicular force is called lift, and the parallel force is called drag. Flight is possible when you can generate enough lift to overcome drag and the object's weight, a consequence of gravity. In your scenario as the airplane ponderer, lift is generated by the wings on either side of the aircraft, but in reality, almost anything can generate lift. You can fly a barn door if you get it going fast enough. The issue is efficiency. To get a barn door to take off, you need to provide enough propulsive force or thrust to overcome drag and allow the lifting force to do its job. In an airplane, the engines generate thrust. With an inefficient wing, like a barn door, more thrust is required to offset drag, which requires a bigger and heavier engine, which requires more lift and creates more drag, which requires more thrust and lift, which, well, you get the idea. Wing design is a matter of maximizing lift and minimizing drag, the first law of gym bro mechanics. In summary, lift good, drag bad, but what causes lift? To answer that question, we need to turn to our friend Daniel Bernoulli, who observed that an increase in fluid velocity leads to a corresponding decrease in pressure. As air passes over an airplane wing, the curved shape, also known as an airfoil, allows the air above the wing to travel faster than the air below. Thanks to Bernie, we know this creates a pressure difference between the upper and lower wing surface, with the upper wing surface having a lower pressure. Since the lower surface has a higher pressure, the air pushes against the wing and generates a force we now know as lift. You may have noticed that just achieving lift does not make for controlled flight. While flight controls are a topic for another day, the same aerodynamic rules apply to the components that keep the plane flying straight and level. So as you drift back to sleep in your economy seat, knees crushed to powder by the person in front of you, allow yourself a moment of gratitude for the wing outside your window that does, in fact, lift bro. Well, that's the end of today's video. For some deeper dives into this topic, see the links in the description below. Also, leave a like and a comment about what factive topics you want me to cover. Until next time, have a good one.